Hello everyone, welcome to another live stream. Hi there. Make it, did you vote? Yeah, I did. I did in fact. I did a democracy. Which, well, you know, as a dictator myself, I don't really support of, but... whatever. Why the F are you streaming? Why not? Who's gonna stop me? Are you gonna stop me? You wanna stop me? You can try. I'm streaming because it is me given right to stream. So... Anyhow... how are you all doing today? You haven't left the stream. No, woke. Remember, the regime knows best. Amen to that. I'm gonna make it a dictator is talking about rights. Yeah, you lower classes wouldn't get it. It's sort of like an elite kind of thing. My life is pretty chat. My life is... Oh, I get it. Okay. If you don't mind, I'm just gonna do the thing that I do. And by that I mean drink coffee and animate Blender videos. Because of a dictator. Hi! Hate the game, not the player. Going to do some school tomorrow. Alright, good night then, Olo. Good night. I came here to eat ass and kick gum. And I'm all out of ass. Alright. Don't mind me, I'm just gonna... Actually, we could play some music in the background. You know what? I scratched that. Do mind we're playing some music in the background first. I could get some different... What are we feeling like today? Jazz? Dance groove? Electronic? Yeah, I think jazz this. I'm here to eat cake and ass gum, and I'm all out of here. Gay ass music. Oh, I mean, maybe. Shut up. Shut up. Irrelevant. The point is, what was I doing? Well, I was drunk. Right, that's the important thing. Hold on. Anything but hopefully Azali. Copyright someone! And also, I don't have the connections required to just ask Azali if I can use their music. All music I listen through your stream is electronic. Actually, I can make it analog. I'll find... Life finds a way, you know? Okay, hold on. What was I doing? Oh yeah, I was doing a bunch of dumb shit for nerds. I mean, you could just ask Azali? Can you play Lusana with Azali? No! I ain't gonna steal music. That feels wrong. That... Listen. That puts me in the position of the bad guy, and I don't want that. What do you mean, self? I can't just go around stealing people's music for my streams. I have done it in the past on rare occasions. I have, because I am a bad guy. But, aren't you God and or dictator? Just do it. Yeah, but I still have a sense of morality. Like, life's a sex, you gotta be a sexist. You literally use AI music. Bitch, this is not AI music. This is from Sounds Crate, which is Production Crate, for which I bought the license. Stream intro is. Yeah, but stream intro was made by Tefta. I have sentimental value attached to that song. The regime does not know the best on this matter. Honestly, you all... No, hold on. I'm adding this as a rule. The regime knows best. You are all questioning me too much. And that is honestly disgusting. Hold on, rule 42. Instead of meaning of life, it's gonna be the regime knows best. Literally 94, yeah, it is. I'm gonna deny it. Plus, Azali probably will be fine with it. Probably ain't good enough. I need to be certain someone will be fine with it. Not just probably. Where can I listen to Tefta's music? I think it's released in your Saygex. No, not the Saygex. Then ask them. Azali, but they're big. They're big. They're a big channel, and I have a habit of getting ghosted by people. I don't know how much more my fragile heart can take, you know, honestly. You were smited? Listen, I've already reached my getting ghosted quota for this month, okay? There are limits. There are limits, in fact. I can't tell if music is too loud or if it's not. There we go. Besides, if I was gonna use someone's music, it would be probably Tom Cardy or Stupendium, because I would prefer to have a manic breakdown while singing. Thank you very much. Anyway, perform the same operation multiplying the same number -1 again. Which one we stop? Then we'll do is we check if our number is equal to 1. So here we need. When I get ghosted, I'll be the ghost. Let's do 0.05, because why not? I'll go backwards. There we go. Life's a ghost, you gotta be ghosted. Make it, will the regime recognize my contribution to the well-being of the regime and its citizens? Oh, I mean, of course, always. The regime always recognizes the contributions of everyone who deserved it, unless they were traitors. So everyone who has contributed to the regime in the past was a traitor. They obviously don't get any credit because that was just a ploy in order to overthrow our regime, and the regime knows best, and you're welcome for protecting us. Hi, the farm main. Well, in fact, I won't go into nothing. We're just talking about how we all love the regime. The regime is great. Make it just being a dictator. Yeah, I mean, obviously. I was chosen by fate, or God, or chosen by due to my skill and merit, whichever one you believe in. Just pick one. But we're getting political. Going from 0 to 1. What do we want? It could be diagonal. No, that would look like us. No, what we want is a clean kind of conditional. There are 30 Trump is printing further money and causing price hikes. For more info, look up Donald Trump inflation rule 34. Did you know that Donald Trump was charged with 34 felonies? Those are 34 different federal rules he broke. To find more about the topic, look up Donald Trump rule 34. The funny thing is that he did actually. Neither skill nor merit, since you can't even muster the courage to ask an artist to use their music. You're trying to like insult my Black Thunder, that ain't gonna work. I feel like you've been here long enough to know that my ego is pretty rock solid. I am immune to the reality that's constantly disproving me. I believe myself to be a god, okay? You can't really use my ego to make me do something. My ego is pretty inert. Lip stitching, chemistry, motion, computer science, apparently. Exactly, yeah. Voronoi. Oh, that could be good. There we go. Yes. Yes, and... yes. Perfection. You can't be a god, but you are a being of pure information. Potato, potato, honestly. Uh-oh, this is... why is this black? Oh yeah, because of the strength, I'm an idiot. Maybe I'm not a being of pure information, maybe I am just an idiot. There we go. Yeah, this could be a pretty solid conditional. Aren't we all idiots in the end? Or maybe the true wisdom comes in recognition of one's own idiocy, which would make us quite intelligent, which would make us no longer idiots, which would make us no longer intelligent, which would make a loop, which wouldn't be broken, which would lead to a paradox, which just effectively means something counterintuitive, which could still exist due to superposition. And so on in circles we go. Being a being of pure information does not imply that the information is true, correct, or that you know how to use it. You're not wrong there, actually. Hi, the Theo. Getting down to a club, getting rid of some batteries. I do want this to appear in a nice way, and I think I know how to do it. Soft color rump. Perfect. The only problem is that it's backwards. There we go. I guess I can just do it like this, cut out the middleman. Man, I'm good. Wow, I am just good. Do not put batteries in your pancakes. That's my shocking recipe. Pancakes with batteries. That's illegal. I'm pretty certain they made it so. There are a lot of puns with, honestly, yeah. And we haven't even gotten to the timing of it all. Mickey, do you have anything for quantum in your list of video ideas? Well, I mean, yeah, I do. It's just that I really don't want to make that video. Because I do have a quantum mechanics series of videos, and the next episode of the series would be just a video about the Schrodinger's equation. But for some reason, I just can't find a single, like, interesting tying theme of the video. And so I really just can't seem to just get myself to do it. Okay. Check if our number is equal to 1. So, oh, which number? There are two numbers. Basic, I'd assume. So right here what we need is text. Oh, there I have a flask of water in the way. There we go. I was standing on my way. Basic. Why is this called basic? It should be called number. And why can't I spell, apparently? What's wrong with me? It took me 4 tries. The video is a representation bored and interesting until it's made. Cactus. Hey, make it, so I had you good in maths. Not really. I'm not really good in maths. What font is that text on your screen? I don't know, the default Blender one. I don't know which one Blender uses as default. Hold on, let me see. It is B font regular. I'm assuming that means Blender. I'm assuming B stands for Blender. The default Blender one. Basic. We check if it's equal to a 1. That's what we do. In which case, let's a couple things. Geometry, there we go. I lost the box. There it is. Oh, I kind of like the idea of it being just black and the box appearing underneath it. I do like that idea a lot. I was planning to have the text appear in the same exact way and have it be white, but I want to challenge you with a quick problem in mind, of course. I'm not really great with maths, to be honest. That French guy Reblax is good at maths. Yes, Reblax is really good at maths. The number one, non-woke one. This one is woke. Make it. What kind of coding is this? This isn't coding. This is Blender. I think this will be fine. Yeah, whatever. It's good enough. From 400 to 450. Render animation. Oh fuck! You can see the basic text though. No, that won't do. That simply will not do. I'm sorry. What happened to my geometry notes? Oh, that's bullshit. Why do they always disappear? There we go. That's correct. Perfect. Are coding and programming the same thing? Effectively, yeah. Very free math proof is gonna be proof by look at it, proof by think for once, and proof by how is this not obvious. No, the best proofs are proof by citation, proof by omission, proof by distraction is a pretty good one. Array of pointers to object being abstracted to an array of objects is just cool. Object-oriented programmers, honestly. Am I right, folks? What's wrong with an array of pointers? I like an array of pointers. I like coding in C. I like an array of pointers. It's simply compiled directly in Blender. Yeah, that checks out. Proof by proof is left to the reader is also a pretty good one. Anyhow, the battery. Your battery charge dropped because you forgot to charge it. My battery charge dropped due to lack of evidence. We are not the same. Okay, so the reaction. Oh yeah, right, manganese oxyhydroxide. Damn it. See, hydroxide chemical structure. The problem is that the problem with I need to log into the archive, don't I? Give me a second. Because we still have no clue what the oxyhydroxide looks like. But to be fair, no one does, so yeah, we're just going to ignore it. It's not gonna be relevant. Let's call this more on the functional side. Listen, I don't have anything against Kotlin, I just really like C. See the chemical name for Titan, please. Is that the biggest protein one? There we go. Now page 259 was it? Oh yeah, I need to borrow the book for some reason. Why? It's an odd night. You know what? I'm fine. You mean manganese oxyhydroxide? Yes. I think that's manganese. I mean, yes, that molecule, I just think it's called oxyhydroxide. I don't know if that's the correct one. You should rewrite it in Rust. No one should. That language is a curse. It only exists for people who want to code in C but don't want to code in C. Okay, so chemistry. Oh wow, how convenient. There's a chapter about chemistry in this textbook. Whoa, that's just what I'm looking for. Believe it or not. Let me guess of how the formula would look based on the name. Yes, that is what it is. Hold on, let me show you. Well, I mean here. Oxyhydroxide, that's what the textbook says. I like C, but I don't like doing a lot of boilerplate, so I just use Rust. Yeah, because as I said, Rust is for people who like coding in C but don't like coding in C. I love boilerplate because I love messing around with boilerplate. The thing is, okay, in C there's a lot of boilerplate, but that boilerplate is there for a reason. And I don't mean is there for a reason like typical boilerplate, I mean like each part of the boilerplate is... I know, no, we're not gonna be on the C tangent. I was about to segue into function pointers, but we're not going to C tangent. Hey Make It, what's the more important useful, C or Python? That depends. If you're talking about the ease with which you would make a program as an everyday user, that would be Python. Because with Python you can just do much more. However, if you're talking about general complete relevance, then definitely C. And there isn't really any other language in existence that could even be a contender. Mainly because every other language in existence can trace back its roots to C. C is such a powerful tool that its own compiler was written in C. C compiler was written in C. That's how mighty it is. What about machine code? Machine code isn't a programming language. You can schedule some observability, no garbage collection. Yeah, but that's precisely why I don't like Java, for this kind of reason. I want to be able to escape the sandbox. It is my God-given right as a programmer to write memory unsafe programs. The fastest and second most used Python interpreter is written in Python. I was saying you like segfaults. Obviously, who doesn't? Extreme is used instead of either chemical or natural, or because of the high manganese content and great purity. The electrolyte is concentrated caustic, usually potassium hydroxide in the range of 35 to 52%, which affords greater conductivity and reduced hydrogen gassing rate compared to the acidic electrolyte of the cell. Plastic is used to provide large surface area for high rate capability. Okay, on discharge, manganese dioxide cathode undergoes a 1 electron reduction to oxyhydroxide. So we get this. That checks out. We start with manganese dioxide, we add water, just a little bit of lemon pepper, you know, and then a single electron, and there we go. And what is HTML? HTML is, well, it's more of a formatting language. I don't know if I would go so far as to say that HTML is a programming language. That's a bit... Yeah, I was about to say that it's a lot closer to markup than or markdown, I guess. When you use HTML and CSS together, it's true and complete. Is it? Oh no, I hate CSS. I don't like dealing with CSS, so... If all programming language root go back to C, then is Python also written in C? Yes. Comedian, you don't understand. When I say everything, I don't just mean programming language. I mean everything. Oh my goodness, are we really going on a tangent already? Programming language C. See if you're okay with, yeah, hold on. Uses. This is one pretty good example in my opinion. Oh, sorry for the flash, but you know, otherwise. Actually, I'm pretty certain I can just do this. Well, no. This is a pretty good example of what I'm talking about. Like, when I say everything, I mean everything. Most programming languages have their compiler in themselves. Do they? Really? I genuinely didn't know that. I thought that stuff for like... Wait, is JavaScript compiled? Not JavaScript, Java, fucking hell. Is Java compiled? Even Kotlin does. Kotlin compiler is rewritten in Java? Oh. C gives you the opportunity to shoot yourself in the foot. C++ gives you a shotgun. No, that's not... Theo, I don't like that quote. I don't like that quote because it is much harder to shoot yourself in the foot in C++ than in C. No, no. C is the easiest language for you to do some actual real damage. Okay? If you want to write a genuine difficult program, like genuine elaborate program with actual issues, C is the best language for it. Because it, on one hand, it's the language that gives you the capability to do some low-level memory, and it gives you low-level memory and CPU access, but at the same time doesn't have any default fail-safes. So it's the best language for it. C++, it can't even come close. What was the question between JavaScript and Java? They're two completely different languages. It's a misnomer. Rust wasn't Lisp were written in pushcards directly. Rust wasn't written in C. Yeah, that's why it sucks. The ancient war of Rust programmers versus C programmers. It rages on. But yeah, C is kind of a bugger. Hold on, let me find another graphic that shows case it's better. A software made in C. Like a map. Because I remember there was a better one. No, I guess this is the best it gets. But yeah, right here you have a... C is widely used for systems programming and implementing operating systems and embedded system applications. This is for several reasons. It's like that meme with, hey mate, you know, like the text messages with, hey, what do you like about C so much? And then just replies with like a 6-hour-long voice message. Show me literally anything but a picture of a cat. Literally anything else will do. Keywords. Tips at misnomer. Misnomer is actually having a lesbian affair with misinformation. And then she is the godfather of all programming languages. Yeah, I would say so. Not Rust. Yeah, because Rust sucks. And that C is old as fuck. It is. C was basically the first modern language. you don't really have any other old languages that have this kind of relevance, because C just worked. That's it. Like, it's just minimal of what you need whilst maximizing the convenience. I like it a lot. Lisp slander, oh my goodness. Hello, I forgot that what we were doing. Yeah, right, we were doing the Handbook of Batteries. That's what we were reading. What a thrilling read it is. Still use wildly. Wildly? Betsig, take your pills. You're comparing them to C, okay? Take your pills. It's fun watching the stream. Bye. That makes people method. Alright, bye, like, and bye. Have a good one. Reacting giving drastic is sloping the stress curve. Of the many structural forms of which exist, only the gamma form functions as well as the alkaline cathode. So it's not prone to become blocked by the SEMS product. In forming manganese oxyhydroxide, the cathode expands about 17% in volume. From zincate ion. As it discharges this as the cell addition. That's curious. Because the flat discharge curve is also slower than the first reduction step before is useful launchers. Yeah, another additional volume of change occurs in the counter direction. Note that this step provides only 1/3 of the capacity of the first reaction based on the reaction. Even further reduction possible but not practical. Okay. Oh, depending the composition of the anode doesn't drain the reaction. This is all neat, but won't really know much. Okay. Let's just start scripting based on this, because that's good enough. By the way, out of hospital today. About time now. Stop insulting God this time. Stop. Listen, next time there's a thunderstorm, don't say I won't get struck by lightning, okay? Don't say that. It's simple as it could be. Just don't. Don't blow me down. Okay. Manganese dioxide and water. We will go into it even more in depth, so... Ah, damn it. Oh, I lost the page in the textbook. There we go. Found the book. And water. Well, manganese dioxide, that would be actually convenient to know what it looks like. Manganese dioxide. Structure. Okay, so in the same structure, alright. Now, we don't want beta, do we? What we want is... chemical, because manganese. Right, no, wait, which one do we want? Gamma. Gamma is the one we care the most about. What's the worst that could happen? Meteor? Sure, okay, why not? Meteor implies the existence of Uteor. Actually, you're wrong, Theo. Meteor implies the existence of Meaty Ant. If a state chemistry of this material is relevant to the law of freshly prepared manganese dioxide and organic synthesis. Alright, so what we would like is the structures, which is the alpha versus beta versus gamma structures. We'll get into that later on, actually. Yeah, for now we don't care. For now, let's just do manganese dioxide. Damn it, on one hand I want to go in depth already, but on the other hand I know I shouldn't. I should slowly really run into it. Okay, so self-reaction will be electron configuration of all atoms, then alpha versus beta versus gamma, manganese dioxide. Next, all the actually no, wait, that's the wrong order. Why the reaction even takes place, then reactions. There we go. You found. Meteor implies the existence of Vigintor. Vigintant. Vegantant. Oh, fuck it. Okay. Which we stand for manganese dioxide and water. How am I supposed to explain... How am I supposed to explain reduction without explaining reduction? Without going in depth. Starting with the manganese, has 2 oxygens. Into all the valence oxygens of all of these compounds. Also, once it gets an electron, screw it. Well, it won't really matter, will it? If there's a damn it! How am I supposed to bite this? Humanito. That's the Terminator's foe. Terminator's arch nemesis. Multiply the numbers. If it's a new result, if it's not, then we multiply the result by a number. Okay, so if it's not, I don't like the idea of it being blue. Actually, now that the more I think about it, the less I like it. Yellow would have been better. Damn it! Oh, why am I changing it now? Why am I changing it? Ah, screw it. I want this video to look nice. We're having a bit yellow. Also, we can, I do believe, lower this to 64. That should be fine. Let's see. With enough light, it should be fine. No, it isn't. Because the thing is, we'll want one red line to go all out, one green line, which means actually, yeah, like this would make so much more sense. As an if. You have a green line, you have a red line. What's more is that they will be backwards, like so. And then right here we'll have the red going off. Remake the whole thing. Wasting time. Okay, I should do brass yellow and moss green. I'm torn. On one hand, I think it's fine, but on the other hand, I don't want to re-render it again. Oh, this also works much better as an animation. Like a color just going to the corner. Why am I thinking about this so much? Because I want it to look nice, that's why. Alright, screw it. Enough. Render animation. Good enough. Do you do any compositing on the animations? No, not really. Take it or leave it or die. Okay. Coffee's not kicking in for me. The problem is that it's quite late and I don't want to scream and wake up my neighbors, which is seriously like slowing me down. It's not letting me spiral off into a manic state, which is what I need. Okay. So we have the reduction reaction, which in water. It is called a reduction because we reduce the charge. That was the reason for reduction, right? I remember it was supremely confusing. Reduction, reaction. Or was it the reducing the oxidation state, which was just effectively the same? Oxidation states suck, and I hate them with a burning passion. They go against everything that I like about chemistry, because what is an oxidation state? Well, it's just an arbitrary value we like gave to molecules, and atoms. I hate it so much. Okay. Okay. Actually, Theo, you would know. Does the reaction, is it called the reduction because it's reducing the charge or reducing the oxidation state? Good night, Italian Mappe, good night. The recording is so professional there. Reduction reactions, yes. Obtains one or more electrons according to electronic notion. So like, whatever. In this case, I'm not gonna say that that's where the name comes from because I don't know that as a fact, but that is how I always remembered which one is the oxidation, which one is the reduction. In this case, actually, because we reduce the charge, do so by introducing electron. Into our yeast charge and water charge. We also bring in we also add in the -1, hence reducing the charge. Now, obviously manganese dioxide and water, they will have a net. They will have a standard net because that's how they're not ions. But if we introduce charge, well, introduce negative charge, this is confusing. Chemists, what's up with the negative electron? Just give it a positive. No one cares about protons, no one does. No offense, protons, though. No offense. I didn't mean like that. No one in chemistry. Because physicists still love you. Reducing the charge. It's to do with the oxidation state. So this is whatever. I just won't say that that's where the name comes from. I'll just leave it as this. Now you may remember from this, okay, in this case we can oversimplify this and we can have it be very simple because we will expand on it in the next chapter. So for now we can have it be simple, although we should probably already dig in a bit deeper into all of them. Now, manganese dioxide. No, this is great. Oxidation reduction is the difference of these two. I see. And also reduces the charge. That's also, in my opinion, much better way to remember it. But to be fair, I am not a chemist, so I need more coffee. Okay. We're looking for sources, good sources on manganese dioxide. Actually, wait, what was the name of that website with the data on? Was it PubChem? It might have been PubChem. Yes, okay. Neat. chemical and physical properties, would it be? No, I don't think so. It would be... Oh yeah, because it's an IH. Wikichem. Net charge change happens occasionally, but not necessarily. Can you really have a reduction reaction without reducing the charge? Because the way I always remember the reduction reactions is that you... Well, you reduce the charge somehow. Is it really reduction of the oxidation state? To be fair, I have been introduced to redox from the point of electrolysis, and in electrolysis, reduction always comes with reducing of charge because it's electrolysis. No, I don't care about applications. I care about properties and applications. I don't care about applications. I care about the bonding. A lot of these are red. H2 plus O2 equals H2O2O. Okay, yeah, that makes sense. Thank goodness I asked. Not a charge by a full redox. Wait, but that's redox and that's not reduction. That's reduction and oxidation. I'm talking specifically about 1/2, because the way I always thought of it is that reduction reduces charge, oxidation increases charge. Hence why in electrolysis, once again, I myself have only like studied this when I was doing electrolysis, so I'm probably not aware of actual redox reactions. Well, electrolysis, it doesn't matter. The point is, so you know, you have on one side introducing electrons, yellow, introducing electrons, so negative, you reduce the charge, and on the other side you take out the electrons, so you increase the charge, so minus minus, so plus. And like the reduction was reducing charge, the oxidation was increasing charge, and together they were just redox. Okay, this is what I wanted to show off. Chemical properties, safety, price. And like, if you want to go, every reduction implies the oxidation of something else. Usually you have a reduction agent to reduce something. Yeah, but I'm talking like, if when you have a reduction reaction, doesn't that always reduce charge? That's basically my question. So, if you have... well, this. This, basically. Okay. One, two, three, four, five, six. necessarily. Example, if you heat copper oxide in a hydrogen stream, you get copper and water. It was reduced. Hold on. So CuO goes to copper and OHH. I know I drew it saying H2O, make it be consistent. Yeah, and that introduces charge. That makes sense. Why don't you make a slope channel to post highlights of your streams if they're funny? Because it's a lot of effort. It's too much effort for me to care. There is on Discord there is a channel just for clips from the live streams. Copper has oxidation state 2, a chemical, an element of copper is at 0. Yeah, I was wrong then. I was just straight up wrong. Thank you, Theo. Thank you. In this case... So the question remains... How do I explain redox without explaining the redox? It's not charge, it's oxidation, two different things. I know, that's why I don't like oxidation state. I like charge a lot, I don't like oxidation states. How do I explain reduction without explaining reduction? Okay, for now, put a pin in it. We'll be back. The necessary for the whole theory of oxidation reaction, though. Yeah, but I come to chemistry from quantum mechanics, and so I really like it when you have like values based on something very physical that we can see, some very like elementary property. You can't work with natural numbers without the one. It's just that this is a very like chemistry, it's the same thing as with acids. And I'm trying to find the example of chemistry that would put my point as well as possible. Oh, so for example, hybridization. Right. When it comes to hybridization, I used to not understand it at all, but then I learned that hybridization is just when you take like a bunch of orbitals and you combine them, which is just, well, taking a bunch of wave functions and combining them. That's simple. So you start with something that's a real measurable thing, and then from it you just describe the property of the electron. I like that. But then on the opposite side of the spectrum, you have stuff like electronegativity, where electronegativity is just like an arbitrary-ish value that we've given to just elements. And I get that that makes it really useful in chemistry, but for me it's really difficult to just grasp or use that topic, Because what is electronegativity? Well, electronegativity tells you how much something wants electrons. Why does it want electrons? Who the fuck knows? It could be due to charge, it could be due to orbitals, it could be due to their configuration. Reasons. Depends on the scenario. And this turns like chemistry from application of physics into a memorization game, where you just need to memorize the values for different elements. And I really don't like that. That's why I don't like oxidation states. Or at least that's how they've been explained to me. Maybe I've just never seen a more intuitive explanation. But the way they've always been explained to me is that they just give you like different values that different elements can be at, without the reason why they can be. Shit, should I do a fucking redox video? Well, I mean, this could be a redox video, I guess. Which just segues back to the original problem. Shit. Okay. I'm glad that I restarted the animation in the background, because there will be a lot of thinking for just this video alone. I like that, because that goes in depth for half reaction. How about instead of battery we do redox? Oxidation state is just the hypothetical net charge an atom has if all its atoms were ionic bonded instead of covalent. Hold on. Where did the charge come from? All atoms were ionic bonded. Wait, why would change from covalent bonding to ionic change the charge? Electronegativity helps the as some were determine where to assign. Yeah, as I mentioned, I know why electronegativity is useful, but I don't like electronegativity because it's arbitrary, and that I don't like a lot. But hold on, how can the charge of an atom, charge of an atom? Oh, it's because you move the electrons around. Is that why? Oh, so for example, if you have two atoms, like this, then they are bonded covalently. So if one of them is way more electronegative, pulls all of the electrons away, when they're bonded covalently, then it's fine. But if they're bonded ionically, then the second atom would keep both the electrons, and as such, the charge of the first atom would change. Is that the oxidation state? So in this case, the oxidation state of the first atom would be 1. Example, OH bond, you'd have O minus H, because the electronegativity of oxygen is... No, you just gave an exact... Okay, so I guess it would be this. I think in extreme cases these will determine underlying reaction structures. I have never seen oxidation states explained this way. That is very reasonable. Yeah, so you're just basically seeing how the charge would change without the bonds. Huh. Thank you, Theo. Thank you. Okay. In that case, we could do just... Let's not do redox, maybe. Let's do oxidation. Or redox? I know where I want to go with the video. I know what the point of this video should be. However, for some reason, I want this series to be comically in depth. Always a pleasure. Thank you. Makes sense. I'm not joking you, I've never heard oxidation states explained this way. Although I'm looking up oxidation state. Libertex, my beloved. Determining what is being oxidized and what is being reduced in redox reactions. Total number of electrons which have been removed from an element or added to an element to reach its present state. You can skip a bit of the redox stuff for now, maybe you can go in there somewhere else. Oh no. No. This entire video is just about the battery. There is plenty of space in this video to fit this in. Not batteries, a battery. Oxidation, and besides, what better video to talk about redox and oxidation than a battery video? Have been removed from an element or added to an element to reach its present state. Okay, like this kind of... Okay, this is how I normally been introduced, with this kind of definition. And that's a bit... well, murky. Oh, and then this, yeah, the memorizing game. Which, like, what the fuck do you mean, usually -2? The fuck you mean, usually -2? I'm sorry, I don't mean to be that guy, but when you're doing physics, then you don't get something like, oh yeah, the... I don't know, kinetic energy, 1/2 v squared, but sometimes it's 1/2 v squared plus 0.3. That doesn't happen. No, you usually just do either, you change theories based on the circumstances because you want to be as generous. I'm going off on a rant. I'm ranting again, aren't I? They usually just upsets me to the core. Playing to robot. Tomorrow. It's fine, go to sleep, it's fine. I just need to do my job. Okay. Oxidation states, let's see. Which metals react with oxygen, produce oxide where ions export to you and produce water? Yeah. Term reduction refer to the decrease in mass observed on the metal oxide. Yeah. Assigning oxidation state of the element in binary ionic compound is straightforward. The oxidation state of the element are identical to charges on the monatomic ions. That would track. There usually is without a fine amount of exceptions. New theory, approximately 1/2 mv squared. I mean, no, approximately does happen in physics. Like, 1/2 mv squared, the closer you are to the speed of light, the less accurate this will be. So it does, but it doesn't actually happen in physics because it just says that this is the classical definition of kinetic energy. If you want to go near the speed of light, you need to use the relativistic. It doesn't say usually. I'm ranting. I need to calm down, alright? Okay, I'm fine. I'm an oasis of peace. I'm a lotus flower on top of a lake in the mountains. Yeah, it makes perfect sense now. But you see what I mean, Theo? Like, this makes perfect sense now that oxidation state of the elements are identical charges on monoatomic ions. Like, yeah, with your definition it makes perfect sense, but without it, I would just be confused. Button doesn't hold up due to OO bonder. Rules for assigning oxidation states. I hate this with every fiber of my being. Okay, give me define oxidation state. This could be better. Oh, shucks. I'm sorry. I'm playing with a bunch of 3D printed parts because I'm... well... chemistrydictionary.org. Well, if anyone would know, it would be them. 1 half mv squared plus jk unless... Oxidation number of an atom is the charged atom would have the components composed of ions. The number of electrons an atom gains or loses when bonded with the other. Okay. Gains or loses? Wait, so it's magnitude. Gains or loses to form that compound. When any atom has different oxidation number than expected, we can calculate that by looking at how much charge is needed to achieve 0. Okay, I need to focus up here for a second, I'm sorry. Oxidation number is the number of electron atom gains or loses to form that compound. There are rules to calculate by looking at how much charge is needed to achieve 0 from each atom. Some oxidation numerical with 0. Oh no, there are the rules again. Hold on, but when does it start? Hold on. I'm confused again. So for example, here's how I imagine it, right? I'm probably wrong, I imagine, but when you have hydrogen and oxygen, for example, then oxygen pulls onto the electrons way harder than the hydrogen. Hence, if we replace this bond from a covalent into ionic, then this would be O minus 1, and this would be H plus 1. But where do you draw the line? Like, when does an electron start belonging to another atom? Because in one-on-one, look at electronegativity. Yeah, but like in one-on-one, that's simple, makes sense. Look at the electronegativity. But what if you have like, I don't know, something more like this? A very normal molecule that everyone's familiar. This is, you know, just standard molecule. Like what then? Or something even more complicated, like I don't know, caffeine or something like that. So in caffeine, when does an electron start belonging to another atom? Like the values assign electron to the one with high electronegativity. Okay, but if you have something like, I don't know, A, B, C, like this, and right here you have electronegativity of 1.2, right here 1.4, and right here 0.6. What then? Or does it do it on a bond-by-bond basis? So you just disregard the C completely. But shouldn't then C be pulling as well? So shouldn't this electron be actually closer because C is pulling from the other side? You look only at the bond separately for this hypothetical. Okay, for this hypothetical, so are the scenarios in which you are not looking at the bond separately? Disregard C, something Making could never do. Yeah, that's... What I'm looking for is that, like, given a molecule, a method for figuring out the oxidation states. That's what I'm looking for. Without any BS rules that are usually true. I don't like them. We look at the bonds in isolation. Okay, here. But you keep saying here, so there are scenarios in which you don't look at bonds in isolation. I'm sorry I'm being so nitpicky, by the way, but... but that's just the way I think. That's just the way I am. I need to have a rule. A rule that actually works. And not this kind of rule. IUPAC. Oh! Oh! Comprehensive definition of oxidation state. That sounds like something I would be interested in. Please just let me download for free. Yes! Okay, I don't mean to be that guy, but if I'm looking for a solid definition of an oxidation state, and if I won't get it from comprehensive definition of oxidation state, then I think I should just give up. Oh, algorithm of... And it's just 9 pages. I'm sorry, it's just beautiful. Okay, let's do it. I like it a lot. Wow, alright. Hold on, first let's check up on the animation, because we don't want to be wasting time, said make it. If it's not, then we multiply the result by a number. Okay, so then what we want is red. Save it as new result and repeat the process. So we'll have 4 of them. After the actual, no. I don't know what the dark stream is. No, we're family friendly here. Unless it comes to free printers. Anyhow. Okay. This right here, let's move it by 4, let's move it by 2, let's move it by -4. Now let's vanish all of these, we don't need them. Well, keep them like so. In memoriam, and then a curve. Actually, a better one would be just 2 of them, now that I think about it, yeah. Yeah, this probably would be better. There we go. And then let's make it look nice with a puff curve. But thank you, Theo, for convincing me to actually go into oxidation. My once hated. I'll get through the gold book segment. Well, the segment of the gold book, I mean. And I'll see. Which country does the oxidation state belong? Anarchist when they anarchists when they realize that their molecules have an oxidation state. Anarchists when they realize they have a prostate. Okay, this. Now we increase the array. Perfect. Then the form curve, simple as it could be. Perfect. There is a more proper way to do it, but I'm fine with this. Wait, no, like this. There we go. I am fine with this because I don't care too much. Now 0.1 on these as well. Let be. Ideally, we like it to be on the inside of this. It's a bit thin in it. Yeah, it's a bit thin. 0.1 should be actually perfect size, which means if we change it from 0.1 to the 0.09, it should just fit in. Perfect. And then we're just gonna have it be white, have this be red. A bit of a nicer red. There we go. And a bit brighter. Perfect. And then move to the other one. Always a pleasure to oxidize, my friends. Arson. Just arson. Yeah, the bottom text is a bit... Ah, there we go. That looks pretty nice. Yep. That's quite neat. Perfection. Okay. I don't think I have enough coffee for this, but let's try it. Oxidation state gives the degree of oxidation of an atom in terms of, first of all, actually, wait. This. First of all, very important, very crucial. Sources. Oxidation states. There we go. Perfect. Now, let's do it. Oxidation in terms of counting electrons. It scales trends in redox and acid-base properties, as well as in physical properties such as magnetism, and is a key component when tracking the course of chemical reactions. Thus, the concept of oxidation states is important, and so is an agreed-upon definition of what oxidation state is, and the algorithmic manner in which it is to be calculated. In the absence of the actual definition, algorithms have thus far been used to define oxidation state. Ah. This recommendation proposes a definition of oxidation state based on ionic approximation of chemical bonds, illustrated on the molecular orbital scheme and deduced and deduced from electronegativity considerations. Two algorithms are formulated for diminution of oxidation state in molecules. Ions and expected solids are illustrated in an example. The minimum oxidation states to be well defined and becomes ambiguous are exemplified. Moving outside these requires additional measurements from runoffs, estimates, or plain postulates. Specific uses that justify no new oxidation states are also explained. That's a fair bit annoying. Honestly, I am... It's not great. It's already not great. This present authors have published a comprehensive technical report that provides summary of this. Okay. Definition. A recommendation has a normative side that suggests what should be done and a practical side that reflects common use. The normative side is generic. Oxidation state is the atom's charge after ionic approximation of its bonds. The atom's charge is the ionic charge, a valence electron count relative to the free atom. For the sign of the ionic approximation, but only on the current use common values. The atom's contribution to the bonding of the atomic orbital energy as illustrated in figure 1. Okay. Right. Nobody so far has bothered to define this, so we will bother now. I mean, they're not quite saying it. They're saying that no one has bothered to define it yet, so this is the best we can do. Because there are still things that are outside the definition. But I suppose that makes sense. There will always be things. While AA bonds are divided equally, the ionic approximation of AB assigns the bond's electrons to the atom that contributes more to the bonding. Therefore, the contribution does not concern the electrons' origin upon bond formation. The final allegiance. My goodness. Add 2 electron, add 2. The concept is not taken with abstraction to start using quantum mechanical calculations to obtain oxidation states. Okay. So this is the concept. Right. Practical side, in an AA bond, the two atoms are not always equivalent. Were extrapolate ionic, the charge of this nitrogen would be +5, and the terminal one -3, suggesting unusual OS values. Narrow to reflect the normal common use of oxidation. Thus, the oxidation state of an atom is the charge of this atom after ionic approximation of its heteronuclear bonds. Okay. Common use of the approximation obtained from the electronegativities rather than onto schemes. Of several scales, because in Appendix B of Reference 1, only the Allen electronegativity is truly independent of oxidation state, since it relates to the average valence electron energy of the free atom. As if the bonds implied were abstracted away, the ionic approximation now assigns the bond electron to a more electronegative partner. Right. Right? Right. Energy. This is energy. This is a plus and a minus. Right? Because... Shit, I'm lost. The ionic approximation by electronegativity has a caveat due to electron allegiance introduced in section 2. When the more electronegative atom is bonded as a Lewis acid, its acceptor orbital is at high energy. Under ionic approximation, the less electronegative Lewis-based donor, typically electrons from metal, is therefore assigned the electrons it's supplied to form the attack bond. Reveal itself via attack formations being reversible. Okay. I'm assuming this would make sense if I knew about the Allen electronegativities. The algorithms are core part of this. Yeah, because, I mean, algorithms are the definitions. That's the thing at the very beginning. Alright, let's do it. Lewis formulas. Right. Oxidation state equals the charge of an atom after its homonuclear bonds have been divided equally, and heteronuclear bonds assigned to the bond partners according to Allen electronegativity. Except when the electronegative atom is bonded reversibly as a Lewis acid ligand, in which case it does not obtain that bond's electrons. Right. Okay. This makes sense. Wait, no. Am I understanding this term correctly? Molecules compose only one element. Okay, so this, basically, two oxygens. Wait, wasn't the nitrogen example specifically counter to that? Except when the nitrogen is bonded reversibly as Lewis acid ligand. I guess that's okay. Heteronuclear bonds assigned to the bond partners according to Allen electronegativity. Alright, this is workable. I like this. I like that a lot. Okay, and then the second one. Heteronuclear bond orders are summed at the atom as positive if that atom is electropositive partner in a particular bond, and negative if it's not. Makes sense. Okay. Alright, alright. Alright. So, except when the electronegative atom is bonded reversibly as a Lewis acid ligand, which, yeah, asterisk, am I right? Fucking hell, it's fine. This is really good. This is really good. This is, in fact, good. Oh, okay. Still rendering. This is good. This is good news. Yeah, I need a break. The thing is, I can't yell because it's really late at night. I don't want to wake up my neighbors. And so it's really difficult for me to really get going and get energetic. So unfortunately, good night. Oh, yeah. So I'm gonna go now. Work on the videos in quiet. Work on some additional things. Work on the do that. I guess that'll be it. We've done a lot. Thank you so much, Theo. Because this... Yeah, I'll just explain the redox. Well, oxidation mostly. Mostly oxidation. Redox will be kind of the... Do take your break. I don't know, I'm not gonna take a break. I'm just going to do it in quiet because I... I'm gonna be moving out of this place in like 2 weeks. I don't wanna mess up and last the very end. Read some electron vibes. I plan on it. I plan on it. Thank you. And so there we go. I suppose for now that'll be it. Thank you everyone so much for watching, and have a great day. Bye.